Welcome back. We've been working with similar figures and proportions, but today we're going to take a break from similar figures and we're going to look at how parallel lines create proportions. It's nifty stuff, so let's go. The first thing we're going to look at is called the triangle proportionality theorem. In any triangle, a line parallel to one side of a triangle separates the other two sides proportionally. So if we look at this, it says if XY is parallel to RS, then what happens is that this segment has the same proportion to this segment as this one has to this one. Mathematically, that looks like this. RX is to XT, the same that SY is to YT. So let's take that for a test drive. In this problem, we need to find X. So we have a triangle with two parallel lines. And with those two parallel lines, we know that the small segment has the same proportion to the big segment as this small segment has to this big segment. So we can set up a proportion. 6/18 equals X plus 2 over X plus 22. Now, I always like to save myself some time and reduce if I can. So 6/18, that reduces to 1/3. So let's rewrite this. X plus 2 over X plus 22. And now we can cross multiply. So we have X plus 22 times 1 equals 3 times X plus 2. We'll distribute that 3. So we get X plus 22 equals 3X plus 6. Can subtract X from both sides and subtract 6 from both sides. So we get 2X equals 16. Divide both sides by 2 and X equals 8. Scrolling down to this one, we've got a triangle with two parallel lines. So we know that the small side has the same proportion to the big side, which they haven't told us, but we can figure it out because we just have to take the length of that whole thing minus 8. So we can say that that's 20. So 8 is proportional to 20, the same way that 10 is proportional to 3x minus 5. So 8 goes to 20. Like 10 goes to 3x minus 5. And again, why don't we'll reduce this. 4 goes into both of those. So we've got 2/5 equals 10 over 3x minus 5. Now we can cross multiply. 50 equals 2 times 3x minus 5. Distribute the 2. So 50 equals, 6x minus 10, add 10, 60 equals 6x, so x equals 10. Okay, let's try another one. This one looks a little bit more complicated, but if you break it down into steps, it's really not that bad. It says that in GHJ, HK equals 5, so let's write that in, and KG equals 10. We'll write that in also. And JL is 1/2 the length of LG. Okay, so if we say that JL is X, that's half of the big one, so that means this one is 2X. Okay, it says, is HJ parallel to KL? So we're wondering if these two lines are parallel. If they are parallel, then 5 would go to 10 the same way that X goes to 2X. So we're going to set up a proportion and we're going to ask, is X over 2X equal to 5/10? And to solve that, we just have to cross multiply. So 2X times 5 is 10X. X times 10 is 10X. So yes, those are equal, which means that HJ is indeed parallel to KL. The next thing we're going to look at is called the triangle midsegment theorem. There's a lot of words in here, so buckle up. It says if x and y are the midpoints of RT and ST. So let's mark that. We've got x and y are the midpoints. Midpoints cut something in half. So Rx and XT are congruent, and then TY and YS are congruent. Okay? Then we know that XY is a midsegment of the triangle. So that means that this is now called a midsegment. Okay, what's next? And it's parallel to the third side. Okay, so that means this is parallel to this. And this is the fun part. The midsegment is half the length of this bottom side of the triangle. There's a lot going on here, but let's see how it works. This says find the value of x. Okay, well, see, we've got these congruent markings here, which means that C and B are midpoints, which means CB is the mid segment. So if CB is the midsegment, then we know that x plus 19 is half of x plus 29. Or we could say that if we have two x plus 19s, we'd get the same length as the big side, x plus 29. So now we can go ahead and solve for x. So we'll distribute this. So we've got 2x plus 38 equals x plus 29. Okay, and we'll subtract x. And well, we could subtract 38 from both sides. Okay, so that means we get x equals -9. Let's try one more like this. Here we have another triangle. Again, we've got some lovely congruent markings. So we know that Q is the midpoint of YX. R is the midpoint of WX. So QR is the midsegment. That means that if I have 2x minus 3's, I'll end up with an x plus 9. 2 times 2x minus 3 equals x plus 9. We'll distribute the 2. 4x minus 6 equals x plus 9. Subtract x, add 6. We get 3x equals 15. So x equals 5. Not so bad, huh? So we'll put aside triangles for the moment, and we're just going to look at lines. We're going to look at parallel lines and proportional parts. So the first part says, when 3 or more parallel lines cut 2 transversals, let's just pause there for a second. So we have 3 parallel lines, okay, and we've got 2 transversals. That's what it said so far. Then we know that it separates the transversals into proportional parts. So if those 3 lines are parallel, then we know that A is proportional to B just like C is proportional to D, or A over B equals C over D. If the ratio of the parts is 1, then the parallel lines separate the transversal into congruent parts. So let's take this concept for a test drive. Here we have 3 parallel lines, and we have 2 transversals. So then we know that this segment is proportional to this segment, the same way that this one is to this one. Again, they don't give us this right here, but we can figure it out by just taking 10 minus 4. So that's 6. And now we can set up our proportion. 2x minus 10 over 9 equals 4 over 6. Let's reduce this to make our numbers a little bit lower. 2x minus 10 over 9 equals 2 over 3. That looks better. So we can cross multiply now. 18 equals 3 times 2x minus 10. Distribute our 3. 18 equals 6x minus 30. So I can add 30. Let's go up here. So I got 6x equals 48 and x equals 8. Same thing with this one. We've got 3 parallel lines. We've got 2 transversals. So we can set up our proportions. 6 goes to 5 like 12 goes to x minus 1. 6 goes to 5 like 12 goes to x minus 1. Cross multiply. 6 times x minus 1 equals 60. So 6x minus 6 equals 60. 6x equals 66. So therefore, x equals 11. Now, this last one is interesting. We have parallel lines, and we have our transversals, but they don't tell us anything about this side, or do they? We've got 2 congruent markings here, which means that if those 2 segments are congruent, the ratio of these is 1. If these equal each other, then these equal each other. So 5x minus 7 equals 2x plus 2. So 3x equals 9 and x equals 3. So there we go. We weren't working with similar figures this time, but we got to see how parallel lines can create all kinds of really cool proportions. So good luck, have fun with your homework, and thanks for being here.